In this video, we are going to see how to control DC motors using L293D motor driver IC in Raspberry Pi 4. L293D driver IC used here is capable of controlling two DC motors. Let's understand the circuit first and proceed with setup. The components required for this project are DC motor, 2. Raspberry Pi 4 Model B with Raspbian OS installed. L293D driver IC. Let's see about L293D. L293D is high-current half-H bridge drivers. These are designed to drive inductive loads such as relays, solenoids, DC and bipolar stepping motors and other high-current and high-voltage loads. It gives output current of 600 mA. Here is the pin description. So how does this circuit works? From the circuit diagram, the Raspberry Pi PO pins 18, 23, 24 and 25 have been connected with L289D driver inputs 2, 7, 10 and 15 respectively. This will in turn control the two motors connected with driver outputs 3 and 6 for motor 1 and driver outputs 11 and 14 for motor 2. When active high is given to driver input 2 and active low to driver input 7, the motor will rotate in clockwise direction. When the inputs were reversed, the direction of rotation will be anti-clockwise. The below table describes how to control the forward, reverse, left and right direction of the wheels of robotic car using the above logic. When GPIO 18 is given active high, then motor 1 will rotate in clockwise direction. Consider motor 1 is our left wheel. If left wheel rotates in clockwise direction and motor 2 is off, then RC car will turn right. And if right wheel rotates in clockwise direction, that is active high input in GPIO 25 and motor 1 is off, then RC car will turn left. When both GPIO 18-25 are active high, and GPIO 23-24 are active low, then both the motors will rotate in clockwise direction, and the RC car will move in forward direction. When both GPIO 23-24 are active high, and GPIO 18-25 are active low, then both the motors will rotate in anti-clockwise direction, and RC car will move in reverse direction. This is just a setup of connecting to motor driver, and we are not sending the control signals from Raspberry Pi yet. The Python Flask application to control the motor will be explained in further part of this video. Before proceeding further, install Flask using pip by this command. Here we are going to make use of our pi.gpio package. It provides a class to control the GPIO of Raspberry Pi. This package is not suitable for real-time applications, because of Python will be busy in garbage collection, which cannot be predicted, and its multitasking OS and another process can be given higher priority over CPU, causing jitter in the program. Let's start coding. This is the folder structure of our project. Step 1 is to create file index.html inside templates folder. Flask will look for templates in the template folder. So, create the file index.html inside template folder of the main module. Use string interpolation, variable underscore name, to print the motor input status, which will be provided in keyword arguments. In user interface, UI, shown in figure 1, we have 5 action buttons: straight, reverse, left, right, and stop. While clicking on straight button, the /straight hyperlink will be called. In the same way, for each button the action path variable will be changed to move the wheels in desired direction. Step 2 is to create file app.py. Create a Python file app.py in the main module. Import the library rpy.gpio and set the pin mode. There are two types of GPIO mode: GPIO.board, which uses pin numbers, and GPIO.bcm, which uses GPIO numbers. Refer the pin configuration figure. The center 2 rows are pin numbers, and the outer rows, first and fourth, are GPIO numbers. In our code, we are setting the pin mode to GPIO.bcm as shown. Now define the GPIO pins 18, 23, 24 and 25 as output. GPIO.input is used to read GPIO status, and GPIO.output is used to write GPIO status. The render_template method is used to render a template. The name of the template and the variables that has to be passed to the Jinja 2 template engine as keyword arguments will be provided in this method. On load, all the motor input status will be read and passed to the template using API. For each actions passed in the path variable from user interface, the GPIO output will be set accordingly using this code. For example, when straight action is triggered, set the variables motor in 1 and 3 to GPIO.high, and motor in 2 and 4 to GPIO.low, which will lead to forward motion of the RC car. The motor input status of GPIO pins, for straight action is shown. Step 3 is to run app.py. Run the app.py using this command. After the application runs successfully, open the application in default port 8080. The index.html template will be rendered on load along with motor input status. Now, we are all set to control our RC car using the motor controller UI. Happy driving!